Hello! In this video, we'll extend the single cycle processor to handle more instructions. So far, we've just handled a small set of instructions in the RISC-V instruction set. We've handled load word, store word, branch on equal, and 5 R-type instructions, add, subtract, and, or, set less than. So there are many other instructions, and in this section we'll support 2 new ones, add immediate and jump and link. But most importantly, I'd like to convince you that adding the new instructions is not all that difficult of a task. You just need to understand what the instructions do, think about what the data path and controller already can do, figure out the differences, and usually make small modifications accordingly. So let's start out with an add immediate instruction. So add immediate is like add, but the second source is an immediate rather than coming from the register file. So it's similar to the R-type instructions that we already have, and I'd expect we could reuse most of the data path. The difference is that second source is coming from the immediate, so we need to change the ALU source mux to choose the second source from the immediate instead of from the register file, and we need to make sure that IMM source is correctly set to pick the immediate. So here's our truth table for the main decoder, and the rows in black are the ones we already built for what the processor should do. And now let's add a new row for add immediate. Add immediate has an opcode of 19. It's like add or other R-type instructions. So reg write is 1, just like in a regular R-type instruction. We want to put our result back in the register file. Mem write is 0 because we're not accessing memory. Result source is 0 because we're taking our answer from the ALU result. Branch is 0 because it's not a branch. ALU op is 1, 0 because we need to look at the function field to figure out what instruction it is. But the difference is in these 2 columns. ALU source is 1 instead of 0 because we want to take our second source from the immediate rather than from the register file. And IMM source is 0, 0 because we need to treat that immediate as an I-type instruction and assign extended accordingly. So here's our full data path with that immediate. And start with the program counter. Following this blue line, we read out the instruction. We send the instruction up to the control unit to generate our control signals. The register file reads source 1, and we also send the immediate down to the sign extender that extends the I-type immediate. ALU source is 1, so we choose the second source, source B, from the sign extender. ALU op is 1, 0, meaning we should look at the instruction, and the instruction is an add, so we make ALU control 0, 0, 0 in that ALU decoder, and we do the register file plus the immediate. Result comes out here. Result source is 0, so we choose our result from the ALU. Bring that result back around to the right data port of the register file. Reg write is 1, so we write our answer back to the register file. IMM source was 0, 0, telling us to treat the immediate as an I-type. Mem write is 0 because we don't want to write to the memory, and branch was 0 because this is not a branch. And that wraps up everything that's different about add immediate. It's a pretty simple change. All we needed to do was add a new row to the main decoder. That was the same as the R-type row, except IMM source and ALU source were different to choose the second source from the immediate rather than the register file. All right, that one was pretty easy. Let's try the hardest one I can think of, jump and link. That's maybe the most different than anything we have so far. But even so, it's still got some similarities. It's similar to branch on equal. Difference is that jump is always taken rather than being conditional. Because jump is always taken, we need to make sure PC source is 1 to take it. Another difference is that the format of the immediate is different. JAL is a J-type instruction, so we're going to need to enhance our sign extender to handle this fourth format of immediate. And finally, jump and link needs to compute PC plus 4 and do the link part by storing that in the destination register to know where to come back from. Now we already have hardware computing PC plus 4, so we need to add another input to the result multiplexer to choose that PC plus 4 as the answer to write to the register file. So let's start by handling PC source. PC source, we wanted to make true to take the branch target address when it's a branch and the answer was 0 for branch equal. For jump, if it's a jump, we also want to make PC source 1. So let's add this OR gate to make PC source true anytime we're doing a jump. Next, let's add a fourth option to the sign extender. So now when IMM source is 1, 0, we want to handle the J-type instruction. For J-type, the jump destination was kind of swizzled around in the top 20 bits of the machine language instruction, and so we need to put in the implicit 0 because it's always even, put in the other bits of the instruction in the right place, and make our immediate. Finally, we need to change the main decoder for jump and link. So when the opcode is 111, this is a jump and link. And let's think about what it should do. It needs to write the destination register RD with PC plus 4. So we make reg write 1. Immediate source is 1, 1 for this new J-type instruction we handled. ALU source doesn't matter because the ALU is not doing anything. Memwrite is 0 because we're not writing to memory. Result source is 1, 0 because we're going to provide a new input to the result mux to take the value from PC plus 4. It's not a branch, so branch is 0. It's not an ALU instruction, so it doesn't matter what ALU op is because we're not using the ALU. And let's make this PC update or jump signal. This was also called jump in the previous figure. Let's make that 1. So now putting this all together, our result source mux now can take PC plus 4 and we'll use that result source, take it back around and write that to the register file as our place to come back to after the jump. So that completes jump and link. And just to summarize, the three differences were that the extender has a new format with IMM source being 1, 1 for jump immediates. The PC source logic gets an extra OR gate to tell us that we want to do the jump. And the result multiplexer takes a new input from PC plus 4 that we're going to select to choose the return address to write to the register file.